Eric Darling here with Darling Data. Another day in paradise. Uh, today's video we're going to round out. We're gonna roundhouse kick. If I had the office space, I would roundhouse kick, but I don't have the office space for roundhouse kicks. I would knock over my camera, and then we wouldn't get to talk to each other anymore. It'd be sad. It'd be so sad. We're gonna round out our series of videos on spills in SQL Server by talking about exchange spills or parallel exchange operator spills. If you want to say add a few extra words on that, you can see the query plan over here for it. Now I did get a question on another spills video. It was a fair question. It was how do you fix spills? Well, the answer to that is a little bit longer than just than it would seem, isn't it? So, I mean, first, you want to make sure that you are getting the actual execution plan, and that you are making sure that the spill that is occurring in the plan is running for an amount of time where if you fix it, people will say, "Wow, that's much faster. Thank you. You're the best." So those are the first two things. And then how you fix it, of course, does depend on why it's happening, right? There are all sorts of reasons why spills might happen. Probably most common, you might have just a really poor cardinality estimate, and that can happen because your query is very complicated or because you have done something that intentionally stifles SQL Server's ability to make a good cardinality estimate. Local variables, table variables, things like that. You could have an overly complex query because you stacked all those super readable common table expressions together and screwed the whole joint up. You also might have a very obviously missing index somewhere. I don't know. But how you fix them really does depend on what got you into that situation. It's like fixing anything else. You want to make sure that you understand how you got there and what needs fixing and why it needs fixing. It's pretty important stuff, right? Otherwise, I don't know, you're just layering everything with duct tape and hoping that it stays together, much like my life. Anyway, we're going to look at this parallel spill plan. Now, I want you to just take a moment to ponder the majesty of this magnificent pagan beast. Look at this thing. This is the trifecta, right? Because I have spills on all three types of parallel exchange. There is a gather streams that spills right there. There is a repartition streams that spills right there. And there is a distribute streams that spills right there. That is all of the available parallel exchange operators in SQL Server, and they have all spilled for me because I'm pretty good at writing demos. Now, if you have been watching my videos for any length of time, you will have heard me say how much I hate parallel merge joins, and this is why I hate parallel merge joins. Right? They are awful when it comes to this stuff, and the reason why they're awful is because parallel merge joins, or rather, merge joins in general, much like stream aggregates, expect ordered input. Input has to be sorted so that everything can be done in a nice, orderly fashion and flow right through all the merging and the blah, 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 blah. And so what you end up with is not necessarily, there's no sort in this query. There's like no explicit sorting, right? There's nothing in this query plan says sort or sort distinct or anything like that. But there are things that preserve order in this query plan that are a little tricky to spot. So not this one, but if you look at this parallel gather streams operator, it has an order by at the bottom of it. And this order by means that it is preserving the order of the user, the ID column in the user's table as it passes through here. Preserving order across parallel threads is what leads to things getting all gummed up and slow. even if this query weren't spilling out to disk, or the exchange buffers weren't spilling out to disk, I would still be pretty concerned that, like, when I see this stuff, especially if it has to deal with a lot of rows, because you're dealing with a lot of rows, and if there's any skew, or if there's any just anything weird about the way rows are arranged across threads, that those intra-thread dependencies, keeping all those rows in order across exchanges and buffers and threads and all that stuff, gets really, really nasty. So that affects this one. Right, this one does not have an order by, but it does have a partition column right here. Now, this is the first one that spills, and you can see operator used tempdb to spill data during execution with spill level 0 and one spilled thread. What is spill level 0? Weird, right? What is one spilled thread? I don't know. Which thread spilled? Couldn't tell you. It's all a mystery to me. But then these two other parallel operators, these have much bigger problems. So this one only runs for about 15 seconds, because you got 17 there. Well, 14 and a half. 2.5 there, 17 there. So about 14 and a half seconds in this one. These ones have it a lot worse. This one, well, let's see. Why did you change colors? No, you don't change colors on me. This one is really, I mean, assuming that all of these times are honest and that nothing is screwy about the operator timing code in SQL Server, and we all know it is, then this one only runs about 8 seconds, right? Because we got 124 here and 132 there. This one here is really the problem, right? That's like a full minute and 12 seconds. Like, most of the effort is between these two. This one only gets it a little bit, but we still spill on this one right there because I'm good at writing demos. Something. So this one does have an order by, right? This is the especially long-running one. Oops, I did not frame that correctly. We have an order by at the bottom here, doing the same thing, keeping the users.id column in order. And then we have our merge join here, and then we have our gather streams here, which also has an order by. And so I do want to recount some of the spill level stuff. This is spill level 0 and 6 spilled threads, so 6 out of 8. And this one is spill level 0 and 8 spilled threads. Right? So all of these order preserving operators and order requiring operators, like these merge joins, these are all why I hate parallel merge joins, because it makes queries very susceptible to issues like this. Right? So and the sort of unfortunate thing is that when you run across this stuff, there are certainly ways to fix it. And they range from, just adding a trivial hint like option hash join. So like hash joins, like, they don't require anything to be in order, and they're sort of like the unordered equivalent of a merge join in that they support 2 reasonable sized inputs and big scans of stuff, right? So that would be like I would try a hash join there, option hash join. If the hash join wasn't giving me what I wanted, I might even try just setting this query to run at DOP1, because DOP1 might still be slow, but it's probably not going to be slower than a query that spills on every single exchange operator, because that's pretty painful, right? It might also be a case where you might want to add some indexes that do not keep your join keys in primary sorting order, so that you like this. So like, if you can't add hints, sometimes if you add indexes that would in other circumstances be considered suboptimal, you could get a hash join plan naturally, because SQL Server wouldn't have nice ordered input for things as it is. So like when we're looking at this query specifically, I have indexes on the users table, non-clustered indexes on the users table and the post table, and these both lead with the column that's being joined on. Right, so this one leads with the ID column, this one leads with the owner user ID column. We merge join those here. Those inputs are already sorted, so the merge join works without having to sort. And then up here, we're just using the clustered index of the users table, and the primary clustered index of the users table is also on the ID column. So we just get, all this stuff is ordered in SQL Server. It's like, woohoo, merge joins everywhere, and that sucks. One other thing that's important to sort of pick out here is what the weight stats look like. So what I am not doing, I'm not looking at the query level weight stats here, because the query level weight stats here are going to be disappointed because our dear friend Sam, that's someone at Microsoft, decided that some of these weights that are important would not be important to show you, right? So when we look through these, we quickly exhaust any useful amount of waiting time on these. Milliseconds down here, tiny milliseconds. The only thing that we have that looks meaningful at all, to me anyway, is CX packet, which we have a whole bunch of milliseconds of, right? Look at all those CX packets flying around. Let's see, 1, 2, 6, 5, 8, 5, 7. That is a 7-digit number of milliseconds in CX packet. So we are 8 threads CX packeting around, right? Doing all sorts of crazy CX packet stuff. But the weight stats for the actual weight stats, the session level weight stats for the query itself, have a lot more interesting stuff to tell us, right? So when we look at the session level weight stats, we have some more interesting things in here. We see our dear friend CX consumer. Look at all the CX consumer time we had in there. Right? That's a lot of time, and the max wait time on both of these is quite nauseating. And I mean, if you want to talk about something else that's kind of interesting, the signal wait time on CX consumer and sleep task is also quite interesting for these parallel spills. But sleep task is another one. We've seen this with the hash spills. With the exchange spills, we also see a lot of sleep task wait time pile up. It's about 15 seconds of sleep task wait time in total, and almost 14 seconds of that 15 seconds is signal wait time. So waiting for CPUs to say, yes, you can do something now. And that's also very interesting with the CX consumer waits. That's nearly 29 seconds of signal wait time out of the, let's see, what is that? Oh, sorry, I messed that all up. Let's see, 452959. It's a 6-digit number, so that's 452 seconds of wait time on CX consumer, which the query plan doesn't show you. Someone at Microsoft, man, why? And like 30 seconds of that 452 seconds was waiting on CPU signal, which is bonkers. The CX packet doesn't have that signal wait time thing up there, but it just has a whole lot of actual wait time. And so more signs that your queries might be having problems. So we talked about, over the course of these videos, we talked about sort spills, hash spills, and now exchange spills. Hash spills in row mode will show you a lot of the sleep task wait. Apparently exchange spills will too. Apparently there's a lot of sleep tasks involved with exchange spills. The thing is that the sleep task wait, like I've said before, is associated with like a lot of other stuff. So you can't necessarily like look at a server and say, oh, sleep task bad. But if you're like looking at individual queries, and you know, you're seeing this wait crop up a lot. Like maybe you're just running who is active, and you're seeing like lots of sleep task waits or something. Like or like IO completion if it's a sort spill. That might be a pretty good sign that like whatever is happening in there. Like, you know, unless you're getting an actual execution plan, you're not going to be able to see what operators are spilling in a query. So you might have to like, you know, run SB who is active, get plans, look at whatever plan SQL Server has running for that query, and then like, you know, assume that one operator that requires memory, like a sort or a hash or an exchange buffer, is spilling, and then that's what the either sleep task wait or the IO completion wait is on about. If it's batch mode, you'll see the BP sort wait. If it's batch mode hash something, you'll see a whole bunch of these different HT, memo, delete, repartition, all sorts of crazy HT waits in there. So just stuff to keep an eye on. Like, you know, when you're looking at queries running, well, the wait stats aren't always going to tell you exactly what's wrong, but just like being able to understand that sometimes they can and what to look for in the query plan based on the wait stats that you see is pretty important. You know, it's like sort of like what I've talked about in videos about eager index spools, where you see exec sync waits pile up, in a parallel execution plan while an eager index pool is being built. Like if you're looking at queries running and you see that exec sync weight in the same way that you might see any of these weights up here, up at the top here, like if you see those piling up, you know, just knowing where to look in the query plan based on the high weights you're seeing is a really valuable thing for performance tuners. So at least something to, like, you know, take away from this video is, like, all the videos that I've done on Spill so far is just like either looking at, you know, weight stats as a whole for a server, or looking at queries that are currently running with SP who is active, or like looking at the weight stats at the query level, you know, anything you're doing there. Like knowing what the weight stats that you're seeing can mean in the query plan as far as the bottlenecks goes, really, really good stuff for you to know. So with that, I'm going to jump out a window. Thank you for watching. I hope you enjoyed yourselves. I hope you learned something. If you like this sort of SQL Server content and you would like to express your undying gratitude to me for publishing it, I do enjoy thumbs ups, and I do enjoy helpful commentary. Not hurtful commentary. I like helpful commentary. That's the best kind. If you like this sort of SQL Server content in general, and assuming I survive my jump out the window, you can subscribe to my channel and you can get notified along with, let me drum roll please as I update my subscriber numbers here, nearly 3,809 other data darlings. You can join them in unanimously and with perfect synchronization, getting notified when I post these videos. So that's about it. What was I going to say? Oh yeah, nothing. Thank you for watching, and that's all for today. Sticking the landing on this one pretty good. All right, cheers. Some seltzer for your troubles. All right, thank you.